Okay, I'm recording this starting now. I wanted to play the music before I recorded because YouTube would take it down. Okay, let's do some screen sharing. Look at this picture, first of all. Oh, you guys up in the room here are like, can we play? First, I'll show you this picture that Mr. Tave sent me. He found on his computer. My daughter, she's like 16 now. Here, she's like 2.5 or something. Anyway, I thought it was a good picture. Screen share. Let's get down to business. So this was yesterday's or last day's work. I did some work on YouTube and posted it. Were there any other questions from anybody? I'll make a note. 6E, 6I from inside the classroom. Anybody else? Anywhere? Go once, go twice, go 3 times. 6H, and sorry, something else on the computer. Someone at home say something?
No, I'm good.
Okay. Okay. 5D, 5F, 6H, I, and E, not necessarily in that order. All right, something else comes up, then just scream continuously until I notice. Here we go. Is this recording? I hope it's still recording. Yes, it is. Lovely. Lovely. So these are a little bit like identities. You don't need to copy these down if you don't want to. It will be provided to you. That formula sheet, it's a picture taken from the formula sheet. I say also rule 5. You'll see that when we start looking at the notes, the examples. So maybe I'll just put everything down and then we'll go from there. I know some people are still writing, but just want to say that we look at these various rules. That's where we'll see number 5. Just to be clear, you will see that. If you want to add it into your notes here somewhere, that's cool too. Everybody at home? Anybody at home still writing? Okay. Let's stop the share. Let's pin myself. Make this screen. There we go. Actually, maybe I'll zoom in a bit. Okay, now just something skinnier than my big fat finger to point with. A pencil. All right, so here we go. Here's the rules, summary of the properties of the rules for logarithms. The first one, is nothing new to you. Log, that's a base of b, n equals x. Well, b, that's the base to the x equals n. So this is, again, not new. This is the first thing we did with logs. B can't be 0, or sorry, b is greater than 0 and it can't be 1. So now this stuff is going to be new. Log base b is what it says. N times m is the same as saying log b of n plus log b of m. Okay, so when you multiply them in brackets like this, it's adding them as completely separate logs. That's a property that is true for those. And dividing is subtraction. Notice it's the same base though. Base b, base b, base b, m to the b. Okay, n over m, n minus m. And there's examples here on the right as well. We're going to be doing some examples, but I'm sure you can make this connection yourself. These are base 10 because it's not written. So log of 5 minus log of 4. Log base 3 of 3 minus log base 3 of 2. If you need a minute, if I'm going too fast, you need a minute to kind of sit with something, just please say so. Now look at this. This is log base b of m. M is to the exponent p. We can always also throw that p into the front of it, right here. So the exponent can be a kind of multiplying coefficient. All right, just need a drink. So it shows that here. Log base 4 of n to the 5 times log base 4 to the n. The root of 7, that means that's 7 to the half. Well, we can take that half and put it in the front. It'll be good to have this sheet with you when you're kind of doing questions, just to recheck. Wait, how does this go? How is this one related? Number 5 is the one I said you won't have to memorize. Like I'll give this one to you. These 3 come already, but you're going to get this. And I don't know why they don't include this, because in all honesty, I don't think they would give this to you on the exams. I don't know why they don't give you this one, because you're expected to know it. If they're giving you this, why not give you this? I think these ones are easier to remember. Multiplying is add, dividing, subtract. This one, I remember. These ones, I need to look at the sheet. I often forget these. So log base b of n, different base, and it doesn't matter what the base is as long as it's the same top and bottom. Log base c of n, log base c of b. So what was the base becomes the number on the bottom. The bigger one, and the way I kind of think of it in my head, log n is up, b is down, so n is on top, b is on the bottom. That's how those two relate. And the base doesn't matter as long as it's the same. Another one, I'm trying to give you guys tips for remembering. The reason I'm giving it to you, I'll be honest with you, this year is because there's no provincial exam. So I might as well just give you this one. Otherwise, I would be telling you guys, remember this. So my teaching is still kind of like telling you how to remember it. Log base b of a, if you think kind of like inverse, inverted, 1 over, these two switch. The b and the a becomes a and b. That's shown here and here. 2 to the 5, 5 to 2. Questions about any of that? This one, this is not something that would be given to you. This would be something that I kind of hope you would see. The little number there, that's an n. So it's n to the 1 equals n. So what that means is the base and the number here, if they're the same, it equals 1. When you raise n to the log of n of x, that equals x. This is a tricky one. Maybe I should give you this one too. If I'm going to give you 5, I should give you 7, because 7 is weird. Yeah, I'm going to remember that. And it's, I don't know what you guys can see on the screen, probably nothing. You can't see it there. This is log base n of x. Log base n of x. If it's n to this, it equals x. It's like this cancels this log of n. And gives examples here. The 10 cancels with the log of 10, so that's 16. 5 cancels with the log of 5, it's just 3. B to the 0 equals 1. If you have a 1 here, this has to be 0. And if you have a 0 here, this has to be 1. Let me just see something. Oh, hang on. Okay, examples. I was talking about on the next page. We're actually going to do the examples. Like I'm not just going to show them. I'm going to do them with you. But I do want to say here, like it's got these proofs, these 3 proofs at the top. You don't need to know these. Don't sweat this. So when I say we're doing examples, page 243, I don't mean the proofs. We're skipping down to these examples. Okay. All right. First one, 1A, it says express the following as a single logarithm. So we've got log of 7 plus log of 5. Do you remember already what you do with this? What happens to the 7 and the 5? Multiply. So it's log of 7 times 5, which is log of 35. Okay, any problems with that? B, log of 75 minus log of 15. We multiplied when we added. What are we going to do when we subtract? Log of 75 over 15. 15 goes into 75, 1, 2, 3, 4, 5 times. So it's log of 5. Any problems so far? This marker is clear enough, hey? You can see the screen okay? Oh, there's part C. Log of x plus 5 log y minus 1/2 log z. When we're going to start combining these things, it's good to make these exponents, like make this log of y to the 5. Like I'm going to rewrite this as log of x plus log y to the 5th minus, I guess, the root of z, because it's to the power of 1/2. So then adding these two, dividing this one. So this will be log of, or not adding, I'm sorry, multiplying these two because we're adding. Log of x y to the 5th all over the root of z. Sorry, this is all one log. I didn't write this very well. Let me rewrite it again. Neater. Log of x y to the 5th all over the root of z. That's a very different from like log of something over log of something.
We can leave it like that.
Like this, yeah. There's nothing else you can do unless you wanted to. You could rationalize the z, but in this case, I'm not worried about it because it's log. It's still part of this machinery. Normally, otherwise, I would want you to get the to rationalize the denominator. But yeah, thank you for asking. Okay, again, this is not equal to, just to be really clear, log of x y to the 5th over log of the root z. That is a different animal. So don't make that mistake. All right, 2A. It's asking to expand in terms of log of x and log of y. So we've got log 1000 xy squared. So to separate these, this is 1,000, x, and y. So we have three terms here. So that's log of 1,000 plus log of x plus log of y squared. Now there's two other little things we can do to kind of simplify this. This is the easier one. I think the more obvious one that we can see. This becomes, we just put the 2 in front, 2 log y. Can we simplify log 1,000 without looking at your book for the answer? Does anybody know? How do we simplify this?
Yeah. You do
Oh,
10 to the 100 or 100 to the 10.
yes. So this is base 10. This log is base 10. So it's 10 to the x equals 1,000. Well, so it'd be 10 to the 3. So this is actually 3. Log 1,000 equals 3. Can you guys see how that is? If I write it out in a different color, log base 10 of 1,000 equals x. Another way of writing this, 10 to the x equals 1,000. So x is 3. So if you have log base 10 and then another base 10 number, you can always figure out what the number is. If it's a 1 followed by any number of zeros, the number of zeros is your answer, essentially. So it's 3 plus log of x plus 2 log y. Cool, cool, cool. Cool, 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 cool. B, log of x cubed over the root of y. So this would equal log of x cubed minus log the root of y. If we move those exponents to the front, we've got 3 log of x minus 1/2 log of 7. Am I doing the right question?
Why?
Oh, 7. Why did I do that though? Oh, that's a 4 now. That's weird. Yeah, 7s and y's?
Yeah, no, I don't know.
What is that? Although that kind of looks like a 7. Anyways, thank you. I was looking for the question. I was like, there's nothing here with a 7. Like, what's going on? Okay, so I was 2b. See if I can squeeze in c at the bottom here. Log of, well, the whole thing's rooted. So log of the root of x over y to the 6th, which means that's log of x over y to the 6th, and that whole thing is to the power of 1/2, which is log of x to the 1/2 y to the 3. Can you see that? Because 6 times 1/2 would be 3, which is 1/2. I'm skipping one step here at the end because I'm running out of paper. 1/2 log of x minus 3 log y. Y. Well, and the book does it a little bit weird. I don't like the way the book did it. I'll show you just quickly. It puts a 1/2 in front, like it factors a 1/2 out of both terms. This looks messier to me. I thought if we were trying to expand this thing, then let's do it this way. 1/2 log of x minus 3 log y. Are we okay with this? Anybody at home have questions? Nope. Okay.
That's where I would say.
Yeah, it's true. That's why, because I think last class you were quiet for. Did you see that?
Yeah.
Okay. What? Anyways, yeah, you were quiet at one point. I thought, is Gavin even here
I
anymore?
think I was like sitting back and trying to mute myself. I have to press the space bar, so I was like too far back.
Oh, so much work. All right, number 3. And for those of you at home, I just threw a straight piece of paper, flat piece of paper at the recycling bin, and it flew between the wall and the recycle bin, even though there's no room there. Okay, number 3, convert to the indicated base. 3a, it says log base 5, 43. And it says it wants to go to base 6. The base is 5. And you might be thinking, well, what in the world do we do? Well, if we're changing the base, this is log B n goes on top, B goes on the bottom, and the new base just goes in there for both. So it really doesn't even matter what that base is. So in this case, it's going to be log base 6 of 43. Is it 43? Yep. Over log base 6 of 5. And that's it. B. And then once you do it a couple times, like in the beginning, it's like, wait, what? How? What the? That's a B. To base B. And so you do it a bunch of times, and it's like, yeah, okay, now I know exactly what I'm doing. Base E, that's a natural log. So you could write it as log base E of 100 over log base E of 2. Or you could just write ln 100 over ln 2. Natural log is the base of E. It's the same thing. And then the last example is calculator work. It's December and you get to use a calculator. So this one says log base 3 of 19. And it says evaluate to the nearest hundredth. It's starting to say stuff like that, then you're going to use the calculator. Now, to do it with a base like this, you know what, some calculators actually might allow you to change the base. I'm just going to see if mine does. Yeah, have a look, see if it does. It's good to know how your calculator works. See, mine doesn't. Chances are someone's does. It does? Okay, but I'm going to show you how to do it just in case it doesn't. I'm going to check my other calculator, my non-phone calculator. Log. Yeah, my calculator doesn't. So anyways, the way to do this, same idea as what we were just doing up here. So it's log with a different base, 43 log with a different base over 5. We just make it log base 10 because that's what our calculator will do. So it's log of 19 over log of 3. It is important to make sure that you are punching the right buttons in the right order. So maybe do this with your calculator just so see that you match me. Some of you might have to put log in first. Some of you put the number in first. Now, just so you know, if you're doing this on a test and you've got log 19 over log 3, you don't need to do this middle step if you don't want to. If you're careful and you do things in the right order, like I punch in brackets into my calculator so it knows. Do not mess with these until what's done in the brackets first. So anyways, 2.68. If you didn't get that, let me know. It's good to try these. Next one. Negative 1 over log 5 base 8. Remember, we can look at this as, because of the rules, negative log base 8 5. Remember, they switch. But we still need to log of 5 over log of 8. Sorry, you were going to say something over there, Maya?
No, I was just figuring something out.
Okay, that's allowed. I will allow it. And you've figured something out? Oh, oh,
There's just a different button, and I've been doing the button that takes 10 times longer.
oh, 10 times. It's negative. Don't lose that negative. I just about did. Till I looked at the answer. So I did. I admit it.
Or if we're doing this on a calculator, can we just put log base 3 of 19?
If your calculator will do that, I'm okay with it. That's it. That's all the examples. There were questions from last day's assignment. I'm going to do those now, but those of you that are hanging around, if you don't have any questions, you can feel free to not hang around or hang around. It's up to you. Nailed it. All right. So what were the questions? ABC 5D. 5D. Okay. So this is page 240. 5D says evaluate log base 8 of 1 over 64. So what this means is, if we convert this, I'll just say this equals x. So 8 to the x equals 1 over 64. So this equals 1 over 64 is the same as 1 over 8 squared. And that whole thing equals 8 to the negative 2. Therefore, x equals negative 2. Was this you, Sam, wanted this one?
No, this is me.
Oh, does that make sense?
I see my problem now. I put a 5 instead of an 8, and that's why I couldn't figure it out.
Oh, just because your own.
Just
It's
for
not
me.
very clear. Oh, that's better. Okay, well, you got it now. 5F. Log of x. Okay. Log of x to the a. So this, we would know, I think now, maybe, with the new rules that this equals a, just kind of by looking at it, but you can always also rewrite it. So let's say our unknown is y. We want to know what y equals, because that's what we're doing, we're evaluating this whole thing. Well, x to the y equals x to the a. So y equals a. So this whole thing equals a.
It looks like a 9.
It's an A.
That's probably my problem.
Oh, your own?
It's supposed to be A, and I have a 9. It looks like a 9 to me here.
Oh,
Probably is an 8.
yep, that makes sense. No worries. What's next? 6E. Oh, I have it crossed out on my book here. I don't, because I think the answer in the back is wrong.
Oh,
Yeah, okay.
Yeah, sorry. Yeah, 6 is. I need to make a note, and I think whenever this might have been with Micah or something. I don't know who. And I was like, oh, I need to make a note. I made a note in my book, but I need to make a note in the assignment. So do that soon. So we're gonna skip E and then go to A, B, C, D, E, F, G, H. 6H. So we have log 3 of 1 over 81 equals x. We can rewrite this in exponential form. 3 to the x equals 1 over 81. Who wanted this one? You see where I'm going with this? Like same as the one right above it. I just need to make 81 base of 3. So 3 to the x equals 1 over 3 to the 3 to 3 is 9, and 3 is 27 times 3 is 81. So 3 times 3 is 4. And so then you can just make it 3 to the x equals 1 over 3 to the negative 4. Oops, that's wrong. 3 to the negative 4, x equals negative 4. Cool. H, and then I. Okay, so this is log base x2 equals 2. So x squared equals 2. So what that means is take the root of both sides. So x equals plus or minus root of 2. Does that make sense? It's tricky because you see this and you go, well, what's the same base? How do I don't, what the, just take the square root of both sides. Who wanted that? You're good?
Yeah.
Anybody at home with questions? Oh, they're starting to fade away. All right, I guess that's it, my friends.
See, I would just feel bad. Like, anybody at home have questions?
Yeah, well, it's super funny because they can see me looking to see who's in